Hi guys, in case you missed the PowerPoint for today, it's about parts and types of maps. So we are going to go through that and I will give you what I told to the people that were in class so that you get all of the extra information that I want you to have. So parts of maps are just the little things on the map that I need you to know about. A compass rose is the thing that shows you the directions on the map. It usually has the main directions, north, south, east, and west. So on your notes, if you just want to type in NSEW, that would be fine. Normally, I'm not a fan of abbreviating, but I know you know what these ones mean, so feel free to abbreviate on that. Now, a medium intricacy compass rose might look like this. A really intricate one might look like this. Sometimes it's just an arrow pointing, oh, that was an awesome arrow, pointing north on the map. Now, a map doesn't always have to be having north at the top, so that's why it's really important to have a compass rose. The next part that you need to know is the legend, and I'll usually call it the key because that's just easier. And it explains the symbols and the use of color on the map. This particular legend is for a road map, so you can see we have highways and interstates and all the other things. Notice that on the compass rose, north is not directly up, so it just again shows what the importance of the compass rose. The next part of the map that you need to know about is the scale. The scale shows the ratio between a unit of length on a map and a unit of distance on the Earth. We can't have a full-size map because that would be the Earth, and we can't really carry that around in our pocket. So what we need is a way to figure out what length on the map equals what distance in real life. And there's two types of scale. We have a ratio scale and a bar scale. So if we look, ratio scale is the part that is written in numbers. It's going to have a 1, a colon, and then some other large number. This means that 1 unit on the map equals, like, say, 30 million of that in real life. And that's a ridiculous ratio, but it's just an example. Or 1 unit equals 62,500 in real life. If we look at the previous slide, I don't know if it'll let me go to the previous slide. It won't. The previous slide, I believe, had a 1 to 250,000. So it was probably 1 inch or 1 meter equals 250,000 inches or 250,000 meters in real life. Okay, the bar scale is the other one on the map, and this is going to show you a particular length on the map and its equal distance on the Earth. So if we look at this bar scale, okay, this length on the map equals 1 mile in real life. So some maps will have both types of scale. Most of them you're going to see are only going to have the bar scale. So that's the one you probably need to be a little bit more familiar with. Okay. For example, here's one. We've got a nice bar scale. This one is in hundreds of miles. This one's a lot closer up, so we have tenths of a mile on this one. So, but this one also has a ratio. So my guess is foot equals 10,000 feet. Yeah, or 1 inch equals 833 feet. I don't know, so must not be inches. Anyway, ignore the ratio scale on that one. Doesn't quite work. Okay, now there are different types of maps that you need to know about, and the first one is a political map. It shows the state and national boundaries, the cities, basically human-created things go onto political maps. We use them to figure out where countries and states are, where cities are. This, for example, is a political map of Turkey. All of these little divisions are their states. They have quite a few of them. This is another political map. This one is of Europe. So it's showing countries, and we've got some cities and stuff. On the opposite side is a physical map, which shows the physical features like landscapes, mountains, lakes, rivers, things like that. It can show elevation using color. Elevation is height above sea level. So for example, this map right here is of Brazil, and it is an elevation map, which makes it a physical map. On an elevation map, the water obviously is blue. The darker the blue, the deeper the water. On the land, the green is the lowest elevation, and then it increases to the yellows and then to the browns, and then the darkest browns are the highest points. So if we wanted to look at what the landscape in Brazil would be like, we know this northern part is largely closer to sea level because it's green, and we've got the Amazon River, and as we move south and southeast, we get increasingly higher, and then we go to the Brazilian highlands. This is another physical map, also showing elevation and actually other physical features, so lakes and rivers and things like that. This is Scotland, and if you'll notice, most of the country is very rugged. They've got a lot of highlands. You can see the browns. Okay. All right, we're going to take an aside really quick and talk about the difference between physical characteristics and human characteristics, because I'll ask you about this during the course of the year. None of this needs to be in your notes. I just want you to know what it means. So, a physical map shows all the physical characteristics and physical features. So, if I were to ask you the physical characteristics of a place, I would want you to tell me about its climate and weather, what kinds of things live there, plants, animals, any of the things like that. What landforms are there? So if I were to describe the area around the school using physical features, I would say we've got the Great Salt Lake out to the west and the Wasatch Mountains to the right, to the east. We've got snow in the winter and it's very hot in the summer. We have lots of aspens and oaks and pine trees. We've got a lot of farmland and grassland. We've got some deserty stuff like sagebrush and animals. Naturally, we have deer, some foxes, lots of little rodents, things like that. So those would be examples of physical features or physical characteristics. Now, human characteristics, on the other hand, are the things that humans have made or that we do. So this would be architecture, meaning buildings, anything culture related. So language, religion, clothing, food, customs, infrastructure, which is basically what gives us our utilities, what delivers our water and electricity. So we have roads and power lines. If I were to talk about the human characteristics of around here, I would say that we have mainly houses with shingled roofs versus, say, if I were to ask about the houses in southern Utah, you'd have houses with tile roofs because the weather is different. Also up here, we have, skyscrapers only in major cities. We mostly live in suburbs. Most people speak English as their first language, with Spanish being the second. If you were to go somewhere else, say like Mexico, Spanish would be the first language. And I'm not actually sure where English would rate on that one. Religion, most people belong to the LDS Church, but say again, were you to go to Mexico, most people are Roman Catholic. So we have lots of different human characteristics around here. One food that's really unique to our area is fry sauce. They don't have that in the rest of the country. And so those are human characteristics. So through the rest of the year, when I talk about physical characteristics or human characteristics, that gives you a basic idea of what I'm talking about. And back to maps. Okay, climate maps, anything related to climate or weather are going to show on a climate map. For example, this is a climate zones map of Australia. We can see most of the interior is desert or grassland, and is actually most of Australia is quite dry. This little area in the middle is called the Outback. Okay, not like the Outback Steakhouse, just the actual Outback. This one's showing average annual minimum temperature. So this is what the lowest it will get on average in any spot. And you'll notice down here, southern Mexico, we've got, it never really gets below 40, but up here in like northern Canada, it usually gets below 50. So as you go north, it gets colder and colder and colder and colder, but still climate map. Also this is precipitation, meaning rain or snow in California. This one is showing wind speeds in Iowa. One reason you might want to track wind speeds is for tornadoes, maybe warnings for those, or You might want to figure out where gets wind frequently, and maybe you could put a wind farm or something like that there. Economic or research maps use symbols and colors to show economic activities or natural resources. So this is an economic activity map or resource map for Arizona. Notice we have some logos or icons, we have some colors, and we have some patterns. For example, this little crosshatch here is where they mine gypsum. We notice we have some oil and gas fields over in the top right corner. We've got all of these different areas. Look at all the things that they mine in Arizona, and we can tell that because of this resource map. Another kind of that is a land use map. This one is for the former East Germany, which doesn't exist anymore. It's now just Germany, part of Germany. These ones, the land use maps will tell you what kinds of activities occur on the land. For example, this peachy color is going to be field crops like wheat or barley or potatoes, things that you grow on large areas. The dark green is forest. This lighter red is mixed farming. So you get some grains, some vegetables, some ranching. The yellow is urban areas, so that's where you find your bigger cities and things like that. All right, road maps we talked about just a little bit. They show us all the things that we need to get around, and they are used for navigating. Navigating is finding your way from one place to another. Nice example of a road map. This is Pennsylvania. We also have another road map here. This one's a little bit different than the last one. This happens to be of New York. Downtown Manhattan, we can see Central Park and Times Square. So this would be useful for a tourist or someone who wanted to get around from place to place. Notice we have all of these little arrows on some of the streets. This would be really helpful because it is showing one-way roads. So if you were driving around, you would need to know where those were so that you didn't drive the wrong direction in a city you weren't familiar with. Well, it's not good in a city you're familiar with either, but. All right, our last category has some subcategories, but these are thematic maps. They have a specific theme. They're not going to show natural features like the names of all the natural features. It's not going to label things unless it has to for the theme of the map to make sense. For example, our first type of thematic map is a dot distribution map. Notice there are no labels on here because we don't need them. We have a dot where the data is distributed. On this particular map, the data is visible meteor impact crater sites. So everywhere there's a dot, there's a visible impact crater from a meteor hitting the Earth. So the dots are distributed where the data is located. So that's a dot distribution map. The next type of thematic map is a choropleth map. Choropleth. These use values of a color to show you the different values of the data. This particular map is showing people infected with salmonella in a particular outbreak in 2010. The lighter it is, the fewer the cases. The darker it is, the more the cases. So for example, we can see that California and New York have the most cases. Okay. Now, California, there might be a couple reasons why California has the most cases. One, they have more people. It's the most populated state. So there could just be more people likely to be affected. New York is our second most populated state, so that's another reason. The outbreak could have started in California or it could have started in New York. So those might be why some of them maybe have more cases. But as you can see, the choropleth map, you have varying shades or values of the same color, and the darker it is, the more data is being shown, yes. All right, the third type of thematic map, sorry, I had to pause there for an announcement. The third type of thematic map is a proportional symbol map. It will have a symbol on this particular map. It is a circle, and the size of the symbol will be proportional to how much data it's representing. In this particular case, it's representing nuclear meltdown risks. So everywhere we have a dot or a symbol, there is a risk of a nuclear meltdown. The smaller the dot, the less of a risk. The larger the dot, more of a risk. Now, this particular map is a bit of all three so far. So we have a proportional symbol, but notice it's also a choropleth map. Each of the symbols has a color based on the risk. It is also a dot distribution map because our dots are distributed where the risks are located. So it's a bit of both. The next type of thematic map is an isoline map, and these use lines to show areas of equal value. For example, this is total ozone. Each color is its own value. If I were to trace around these lines, oh, that was awesome. And so you could see them a little bit. I'm doing awesome with this. So you could see them a little bit better. These would be isolines, and each one represents a certain value. For example, this color means about 250 particles per something something. Ozone is a gas that is in the atmosphere that blocks UV rays. So everywhere this light green is 300 particles, and so on and so on. Notice we have some nice holes in the ozone layer down here. Those are caused by pollution. That's not a good thing. But the point is you can see the lines. Okay. The type of isoline map that we're going to be working with in this class is a topographic map. A topographic map, okay, that's on your notes to fill in. The type of isoline you have is elevation. These are called contour lines, the lines of elevation. So for example, this is Mauna Loa in Hawaii. This line right here, all the way around the outside, is at sea level. This next line is 1,000 feet above sea level. This next line is 2,000 feet above sea level, and so on and so on. So on a topographic map, each line is an increase in elevation. On this particular one, it's 1,000 feet per line. Okay. As you are looking at a topographic map, you can usually tell where there are mountain peaks because they come up in circles like this. So we have at least 3 peaks, sort of 3.5 peaks right here. You can tell the peak of this particular one, the elevation is 13,000 feet above sea level. As you are looking at one of these maps, the closer the lines are together, the steeper the elevation is. If the lines are farther apart, the slope is more gradual, because if you're going from this point to this point, and it goes from 0 to 13,000 feet, but this point to this point also goes to 13,000 feet, this has to happen in less distance, which means it has to happen vertically. So it's increasing faster. So all of these, the slope is much, much greater. This is a more gradual slope. This is another example. When you look at topographic maps, try and think of slicing the landscape into layers and then tracing each layer and putting those layers on top of each other. And that's what gives you a topographic map. You notice on this one we have 2 peaks, so we have 2 sets of circles. And then we notice that this peak, Baker Hill, is higher. You can tell that on the topographic map because it has an extra set of contour lines right here. So if you ever have 2 or 3 peaks, you can always tell which one is higher because it will have more contour lines. All right, our last type of map is my favorite. I love cartograms. Cartograms are our last type right there, okay? And these ones are a little confusing if you just look at the definition, but when we look at actual cartograms, it'll make a lot more sense. So whatever variable the map is about is substituted for land area or distance. So when we look at a cartogram, things are not going to be their actual land area or the actual distance. That is going to be distorted, and it'll make sense when I talk about them. For example, this is a cartogram of the United States. You can see the basic shape of the US, but in this instance, the size of each state is not its actual size. Its size is how many electoral votes they had in the 2012 election. So if we look, for example, Utah, we had 6 electoral votes, so we have 6 boxes. California had the most with 55, so they have 55 boxes. Notice they're trying to keep the general shape, but the size is totally related to the electoral vote. not to its actual size. For example, our largest state is Alaska, but over here, it's 3 little squares, okay? So on this particular map, again, the size is related to electoral votes, not to its actual size. Here is another cartogram. This one is world population. On this one, each square equals 1 million people. So if we look at the US, we're shaped pretty well, still the same, but look up here. This is Canada. Oh, that was an awesome arrow. So this is Canada right here. Look how small it is. Normally, Canada is larger than us in land size, but they don't have a very big population. In fact, California has more people than California does. Sorry, I said that wrong. California has more people than Canada does. So Canada's really small. And now if I were to ask what country this is, most of people would say Russia. But that's wrong. This is actually China. Russia is up here. It's this little one. Because although Russia's land area is huge, its population is not. So on the cartogram, it's been shrunk down. Our 2 largest countries in the world are China and India. And you can notice on the cartogram, they're blown up quite large. South Korea is bigger than it normally is. So is Japan and the Philippines and Indonesia. So you can see on this one, again, size is related to population, not its actual size. This is another one. This is percentage of adults with AIDS. And you can notice that Africa definitely has the largest problem with this. 1 square equals 10,000 people with AIDS, adults with AIDS. And we'll go over later in the course, later in the year, why Africa has such an issue or a problem with AIDS. Notice that the US, if we look at our key here, has fewer than the world average of cases. So that's good. Notice East Asia has the lowest occurrences of people with AIDS. So these last 3 slides were showing very squared off cartograms that like you could make with craft paper or something, but there are also computer programs that help you make cartograms. I like to call these the blobby cartograms because the computer will shrink or enlarge different areas depending on the data. For example, this one is the United States. You can sort of see like Texas is there and Florida's there. But this is mountaineering fatalities. So people who have died hiking or climbing or spelunking or mountain biking or something like that. And notice in the middle of the country here, we don't have any. It's all squished up. And that's because there's no mountains there, so they can't have mountaineering fatalities. We do have some over in the Appalachians, but they aren't as high and apparently not as dangerous. But over here, where we have the Rockies and the Cascades and the Sierra Nevadas, we have quite a few, also in Alaska, mountaineering fatalities. So these states are blown up bigger. One unique thing right here is Utah. We have a lot of mountains, but we are much smaller than most of the states surrounding us. I'm not exactly sure why. I like to just say we're smarter, but you know, I don't know. I'd have to look it up. This is another one. This is showing how many Walmarts, McDonald's, or Starbucks are in each of these particular states. Notice that California has the most on any of these, okay? Notice on one unique thing, you can look at some data here for Starbucks. Notice that the western half of the US has far more Starbucks than the eastern half, okay? And it's blown up a lot bigger than, say, McDonald's or Walmart. If you know the origin of Starbucks, that makes sense because it started up here in Washington and sort of spread down and then over. The eastern half of the US isn't as big on Starbucks. They get most of their coffee, like if you were to ask for a store equivalent, more people go to Dunkin' Donuts over in the east than they do in the west. And then in the west, they'll go to Starbucks rather than Dunkin' Donuts. Notice Alaska is very small on all 3 of these. And that's because there's just not a lot of people in Alaska, so they're not going to have a lot of these stores. This one is sort of funny. World military expenditures. Obviously, you can tell that the US spends more on our military than any other country. I believe we actually spend 10 times the amount as the next country on the list. So we're very large. Notice Canada is sort of smushed up here because they don't spend as much. They don't have as many people. Mexico, same down here. Notice Africa and South America look like they've been drained of all their money because they're just so squished. This is China, this is Japan, this is South Korea. So you'll notice anything that's bigger than it normally is spends more, and anything that's smaller than it normally is spends a little less. This last one is vehicle markets. So this is how many vehicles are purchased in a particular country. The largest buyer is China, then the European Union, and then us in the United States. Now, if we look at this, obviously this is amount of cars purchased. But we could also look at this and think of the percentage of cars purchased per population. For example, in China, they buy 18.06 million cars. They bought that in 2010. But if you think about how many people are in China, 1.4 billion, that's actually not a lot of percentage of cars based on the population. But if you look in the US, and we bought 11.77 million cars in 2010, but our population is only like 335 million. So percentage-wise, Americans buy more cars per person than anywhere else in the world. If you think about it, you know multiple people that have more than one car, okay? You're not going to find that in China or even most places in Europe. Okay, that's the end of the presentation. If you have any questions, please email me.